Welcome back to day 51 of the Edulexis Python course. Today, we are going to build a practical, real-world project, a personal expense tracker. Up until now, whenever you close your Python programs, all the data vanishes. Today, you will learn how to make your data stay permanently by saving it to a file. We will build this project step by step from absolute scratch. By the end of this video, you will have a working program that tracks your spending, categorizes your expenses, and saves everything automatically. Don't worry if you are a beginner, we will write every single line of code together. Let's look at the finished program running right here on the terminal and get started. Before we write code, let's understand how our program works behind the scenes. Our expense tracker needs to hold items like the expense amount, the category, and the date. While our program is running, this data lives inside a Python list of dictionaries. But to save it when the program turns off, we will convert that list into a text format called JSON. JSON stands for JavaScript Object Notation, and it looks exactly like a Python dictionary. It is clean, easy to read, and built right into Python. This means you do not need to install anything extra today. Let's start by opening our code editor and setting up the file. Open up your favorite text editor or IDE, create a new file named expense_tracker.py, and let's type our very first lines. We need to import two built-in modules, JSON and OS. The JSON module gives us tools to save and load our data easily, while the OS module will help us check if our file already exists on the computer later on. Next, let's define a constant variable called data_file and set it to the string value of expenses.json. This tells our script exactly where to create and look for our data storage file. Keep things clean and separate. Ready? Let's move to initializing our data system. Now, let's build our first function called load_data. This function's only job is to fetch past data when the program starts. Inside it, we use an if statement combined with os.path.exists to check if our expenses.json file is present. If the file is not there yet, it means this is the first time the user is opening the app. In that case, we simply return an empty Python list, represented by empty square brackets. If the file does exist, we safely open it in read mode using the withOpen statement and load its content into Python using json.load. This sets up a perfect, crash-free data loading system. Next, we need the opposite function, a way to save our data back into the file whenever we add a new expense. Let's define a function called save_data that takes one input parameter, which we will name for expenses. Inside this function, we write it withOpen using our data_file variable, but this time we pass the letter W in quotes, which tells Python to open the file in write mode. Then, we call the json.dump. We pass it our expenses list and the file object. We also add indent =4 at the end. This makes the text file nicely spaced and formatted, making it incredibly easy for humans to open and read. With our saving and loading mechanisms completely done, let's build the core feature. Adding an expense. Let's define a function named add_expense and pass our list into it. First, we print a clear section title so the user knows exactly what to do. Then, we gather 3 inputs from the user, the amount, the category, and a short description. Notice that we wrap the amount input inside a float function. We do this because monetary items usually contain decimals, like $5.50, and Python treats standard inputs as simple text strings by default. Let's make sure we convert that correctly. Now that we have collected the amount, the category, and the description, how do we group them together? We create a Python dictionary. Let's build a dictionary called new_item. Inside it, we pair the keys amount, category, and a description directly with the inputs we just collected. Next, we use the .append method to push this new dictionary straight into our main expenses list. Finally, let's print a friendly message back to the console saying expense added successfully to confirm to the user that everything went smoothly. Let's look at how to review these items next. The next vital step is allowing our users to read and display their tracked expenses. Let's create a new function called view_expenses that accepts our expenses list as its input. We start by printing a clean header line. Now, what happens if a user tries to view their tracker before adding any items? To handle this case safely without errors, we write an if not expenses condition. If the list is empty, this condition becomes true, we print a friendly notice saying no expenses recorded yet, and we use a return statement to exit the function early. This keeps our program incredibly robust. If our list does contain items, the program skips that empty check and moves to the loop. We will write a simple, clean for loop for exp in expenses. This loop goes over every single expense item inside our list one by one. Inside the loop, we use Python's formatted string literals, or f-strings, to print out the information neatly. We fetch the details by typing exp followed by the keys amount, category, and a description inside single quotes. We also separate each field with a clean vertical pipeline symbol to make the text read out exceptionally easy to scan on the user's eye. A fantastic feature for any budgeting tracker is displaying the total sum of all spending. Right below our display loop, still inside the view function, we calculate this value. We create a variable named total and use Python's built-in sum function alongside a quick generator expression that grabs that amount field from every dictionary. We then print a neat dashed line separator, followed by our final total spending output. Notice the sh.2f symbol inside our f-string formatting block. This tells Python to round our currency calculation precisely to 2 decimal points, making it look professional. Now that all our individual feature tools are complete, let's tie them together inside our operational heart, the main function. First, we call the expenses equals load_data. This single line runs at startup to retrieve any previously saved data from our JSON file. Next, we build an infinite loop using while true. This keeps our tracker open and running continuously until the user explicitly decides to quit. Inside this loop, we display an interactive text menu showing options 1, 2, and 3, and capture the user's selection inside a variable called choice. With our user's dynamic selection saved inside the choice variable, we use basic conditional routing statements to run our features. First, we test if choice equals 1:. If they type to 1, we call our add_expense function and pass it our main expenses list to register a new item. Next, we write until if choice equals 2:, a branch. If they selected option 2, our program launches the view_expenses function, showing them their financial lists and calculating their complete budget summary instantly. This structural flow is simple, clean, and highly reactive. What happens if the user selects option 3 to quit? We handle this inside our final if choice equals 3:, statement. Before stopping the program, we call our save_data function, passing it our updated list. This auto-saves all information directly to the hard drive, ensuring no entry is lost. We then print a warm goodbye message and run a break statement to exit our infinite loop safely. We also add a final catch-all else statement. If someone types an incorrect value like 9, it prints an invalid choice warning and cleanly returns back to the main menu. To finish our code completely, we go to the absolute bottom of our file and write Python's standard execution boilerplate block if __name__equals _main__, followed by a call to our main function. This block tells Python that this file should execute its main function immediately whenever it is run directly. Take a quick moment to verify your code. Alignment, check that your indentation lines match up perfectly and save your file. Up. Next, we are going to run the script in our terminal window and test out every single path. Together? Let's open our terminal and run our script using the command Python expense_tracker.py. Let's pick option 1 and add an expense for $12.50 under the category Food with the description Lunch. Now, select option 2 as. You can see, it prints out perfectly alongside our rounded total summary. Finally, let's select option 3 to exit. Notice that a new file named expenses.json has instantly appeared in our folder. Open it, and you'll find your data stored safely. Congratulations on finishing day 51. Don't forget to like, subscribe to Edulexis, and see you tomorrow.
Thank you for watching. Like if you learned something, share with your circle, and subscribe for more.